In Notes 1.1, we're going to learn about graphs of equations. So to begin with, if we have an equation and we want to graph it, we can use the rectangular coordinate system that we learned about in section P.7 to graphically represent the relationship between two quantities. This picture, this collection of points, is going to be the graph of an equation. So we often represent the relationship between two quantities using an equation in two variables. For example, y equals 8 minus 3x is an equation in the two variables x and y. If we have an ordered pair, let's say a comma b, that satisfies the equation, that means if it satisfies it, it makes it true, then that ordered pair is a solution to the equation. Then the graph of the equation is the set of all points that are solutions to the equation. So that's really what we're doing when we're graphing an equation. We're graphing the set of all solutions. So throughout this course, one of our goals will be to sketch graphs of equations. So based on the equation, we'll know the graph's general shape and how to graph it. That's going to be our goal. We're going to learn about lots of different types of functions and how to graph it. But for today, we're going to use a strategy that you can always use when facing a new type of equation, and that would be to create an XY table. So if we're creating an XY table, we will choose convenient values for X. We'll compute the corresponding Y values, and those will be points that we'll plot. So if we're graphing y equals 3x minus 4, for today, I want to assume that we don't know anything about what this graph looks like, even though we do. So let's choose some values for x, and then we'll find the corresponding values for y. I'd like to find points near x is 0. So I'm going to choose x values of -2, -1, 0, 1, 2, 3, and then I'm going to calculate the corresponding y value. So I would have y equals 3 times -2 minus 4, so that's going to be -6 minus 4, which is -10. When x is -1, I have 3 times -1 minus 4, so that's -3 minus 4, which is -7. When x is 0, I have 3 times 0 minus 4, so 0 minus 4, which is -4. When x is 1, I have 3 times 1 minus 4, so it's 3 minus 4, which is -1. When x is 2, I have 3 times 2 minus 4, 6 minus 4 is 2. And then when x is 3, I have 3 times 3 minus 4, 9 minus 4 is 5. And then we can go ahead and we can plot these points. Whenever you are sketching a graph, always put a scale on your axes. So I'm going to do 1 square is 1 unit. So I will label some of these lines. And then we'll go ahead and plot the points. So I'm going to plot -2, -10. Then I'm going to plot -1, -7. I'm going to plot 0, -4, 1, -1, 2, 2, and 3, 5. I hope you all recognize that y equals 3x minus 4 is the equation of a line with slope 3 and a y-intercept of 0, -4. So to summarize, if we have an equation of the form y equals mx plus b, that's a typical way that we express it. This is a linear equation in slope-intercept form. There are other forms that we will talk about soon. And in this case, m is the slope, and the coordinate 0b is the y-intercept. So I'm going to ask you to write the y-intercept as an ordered pair. That would be 0, comma b. And the graph of a linear equation is a line. So let's go on to example 2. In example 2, we're looking at a new equation. It's y equals x squared plus 3. Even though you probably already know how to graph this, for today, let's assume that we don't know anything about this type of function. And let's get some ordered pairs that we can plot using an XY table. So once again, for this graph, it's going to be convenient to choose x values near 0. So I'm going to choose x being -2, -1, 0, 1, 2, 3. And then we'll compute the y coordinates. So if x is -2, we would have -2 quantity squared plus 3. 4 plus 3 is 7. When x is -1, we have -1 squared plus 3. 1 plus 3 is 4. When x is 0, we have 0 squared plus 3. So that's going to be 3. When x is 1, we're going to have 1 squared plus 3, which is going to be 4. When x is 2, we have 2 squared plus 3. So 4 plus 3 is 7. When x is 3, we have 3 squared plus 3. 9 plus 3 is 12. And let's go ahead and plot these points. Make sure you put a scale on your axes. So I'm going to do 1 square is 1 unit on both the x and y axes. Okay, so I think I put on enough points on the scale, and now I'm going to plot these. So we've got -2, +7, -1, 4, 0, 3. Then we have 1, 4, 2, 7, and 3, 12. I can't really fit on my graph, so I'm not going to plot that. And then we will connect these points with a nice smooth curve. And I'm going to put arrows on the ends of the graph because the graph continues. It doesn't stop at those last points that we found. So y equals x squared plus 3 is an example of a quadratic equation because it's second degree. The general form of a quadratic equation is y is equal to ax squared plus bx plus c, and its graph is a parabola. So this U-shaped curve is a special curve called a parabola. In example 3, we're going to sketch an absolute value function. So we're going to sketch y equals 2 times the absolute value of the quantity x minus 7. So we want to choose, for today, we're assuming we don't know what this absolute value function looks like. So we're going to choose x values, and we're going to choose convenient values of x. So in this case, because we have x minus 7, rather than centering our points, our x values around 0, it's going to be helpful to center them around 7, because that's when x minus 7 will be 0. So I'm going to put 7 in the middle of my table, and then I will put x is 6, 5, 8, 9. That'll be sufficient. And now we're going to determine these values. So when x is 5, we're 2 times the absolute value of 5 minus 7, which is 2 times the absolute value of -2, which is 4. When x is 6, we have 2 times the absolute value of 6 minus 7, which is 2 times the absolute value of -1, which is going to be 2. When x is 7, we have 2 times the absolute value of 7 minus 7, which is 2 times the absolute value of 0, which is 0. When x is 8, we have 2 times the absolute value of 8 minus 7, which is 2 times the absolute value of 1, which is 2. And when x is 9, we have 2 times the absolute value of 9 minus 7, which is 2 times the absolute value of 2, which is 4. So I'm going to go ahead and plot these points. Put a scale on your axes. So I'm going to do the same scale. 1 square is 1 unit. And we'll go ahead and plot these points. So we've got the points 5, 4, and then 6, 2, 7, 0, 8, 2, 9, 4. And I'm going to connect these points with a nice smooth curve. And I'm going to put arrows on the ends because this graph actually continues on forever. And I hope you remember from previous math classes that an absolute value graph is a V. So this is a V-shaped curve, as opposed to a quadratic, which is a U-shaped parabola.